All right. Thank you, Sir Lawrence, for that very informative introduction. By the way, guys, this is Rodrigo Real Jr., RJ for short, and my task is to show you how to manually compute a multiple linear regression analysis. Oh, well, just a quick trivia. Did you know that linear regression is also called as an ordinary least square? The OLS. So kapag may nabasa kayong study using OLS, ordinary least square, ang ibig sabihin po niyan is linear regression ang ginamit na analysis. Bakit siya tinawag na ordinary least square? That is because the goal of the linear regression is to minimize the sum of square of the residual. Kaya siya tinawag na ordinary least square. Again, the goal of the linear regression is to minimize the sum of square of the residual from the term least square. Now, basically, linear regression involves a lot of computation in order for us to get the desired result. Now, the computation includes Pearson correlation, the adjusted R square, the analysis of variance, and the regression coefficient. What I am implying here is that in terms of data computation, linear regression is a very voluminous and tedious analysis. And we don't want you guys to stress out by showing you a lot of formula. No, ayaw naming pahirapan kayo. Now, because of that, instead of showing you the whole operation or computation of the regression function, what we are going to do instead is to show only the vital point of the manual computation. And in order for you to appreciate this topic, we have decided also to include in the presentation the regression analysis using analysis toolpack embedded on the Microsoft Excel. In other words, iraran natin ang dataset using regression analysis in the Microsoft Excel. That topic will be presented to us by my groupmate, Ma'am Charil Rosario. And then after that topic, we will also be going to run a regression analysis using SPSS software. That is conducted to validate the regression results generated by the Microsoft Excel. Again, I just want to point this out that what we are going to show you is the manual computation of the regression function or analysis. But we will not go to a deep understanding on this because it is quite voluminous in terms of data computation, as what I said earlier, and we cannot afford to show you all how to manually compute all these parameters or values. So we pardon for that. Now, without further ado, allow me to start my presentation. I have prepared here data set, a data set with only five observation. Now, maybe some of you ask me why only five observation. That is because our intent here is only to show you how the manual computation works and also for you to appreciate the whole process of the manual computation. All right? But don't worry because later we will be going to give you a presentation using a true data which is downloadable through the internet. No, actually, this data is all of us has been familiar is already familiar on this data because this is the data that we often use in our discussion with Sir Rec Igia. All right. Now, going back to the data set, we have here two independent variables, and one, of course, one dependent continuous variable using continuous data. Now, before I proceed to the manual computation, let me give you a quick recap again. Recall our algebra, and as what Sir Lawrence said in his presentation just recently, that the linear regression function was adapted using the linear function y equals to mx plus b. Now, this linear function, when used in regression analysis, will also have the same interpretation, but on different notation. Now, again, this linear function, itong y equals to mx plus b, when used in regression analysis, will also have the same interpretation, but on different notation. Magkaiba lang yung notation or yung sign or yung letters, sabihin lang natin letters to make things easier to understand, you know? Magkaiba lang yung ginamit na letters. All right? All right. Okay. Here, as you all see, this is the simple linear regression function. And this is the linear function of we have encountered in our algebra. Now, observe this one, the beta O plus B1 times x1. That is the B1 x1 here is the mx in this function. Right? Si mx pala kay mao din na si B1 x1. While si B is the beta O. Alright? But it has the same interpretation as what I said earlier. Okay. Si beta O is same as this. In technical manner, it is called the uh, y-intercept of the regression line. This is the y-intercept of the regression line. Well, the beta 1 here, and the m here is called as the slope of the regression line. We also refer that as the regression coefficient in terms of regression analysis. All right. Now the y here is our dependent variable and our x1 here is our independent variable. It is also called as the predictors, or in terms of economics, it is called exogenous variable, while dependent variable in economics is called the endogenous variable, or we sometimes call this as the outcome variable. But in this activity, we will only going to call this as dependent and independent variable for consistency or uniformity. All right. Okay. Because our data sets showed that there is there is two independent variable and one continuous variable. Basically, what our approach here is that we will going to use na the multiple linear regression, because the multiple linear regression says that when you have two or more independent variable, then you are belong to me. Yan ang sabi ni multiple regression. Kapag meron ka na palang two or more independent variable, ibig sabihin multiple linear regression ka na belong. Alright? Common sense. Yan lang po. And then, basically in the regression analysis, what we are going to do is to predict this guy, using these two guys. Alright? What we are going to do is to predict the dependent variable, the outcome variable, using these two independent variable, or using these two predictors. All right. Now, since kaya nga sabi dito, since we have two independent variables, then we are going to use the multiple linear regression function. In multiple linear regression function, before we get the value of our outcome variable, or the y, we have to solve first the value of these three guys. We have to get the value of these three guys first. All right, the beta O, the beta 1, and the beta 2. Now these three guys here has its own unique formula. Meron po silang sariling formula para po makuha natin yung value niya. Now, sa beta O, ito po yung ating formula, ang kanilang formula. Sa beta 1 is this one, and the beta 2 is this one. Alright? Now, question, paano po natin makukuha itong value to? itong mga valueng to. So, right? And this one also. Now, meron po tayong table na ginawa dito. Basically, what we are going to do is to get only the individual value of the per observation value of these guys, no? So kapag kang mangyayari niyan, kukunin po natin individually yung value niya. And then we will get the summation. And then that summation value will be substituted in here for us to get the value of the beta 1. For example, our okay, ganito pala. The x sub 1 raised to 2 says that this notation is exactly the same as what it is expressed as. Okay? Sabi niya dito, si x sub 1 daw is raised to 2. So, ang gagawin natin, si x sub 1, i-raise lang din natin sa 2. Alright? Same goes to the other observation. So, i-copy natin, paste natin ng ganyan. Alright? Ganyan lang po. Same goes to the x sub 2 raised to 2. Kunin natin yung value neto. Raise na natin into 2. Then, dito naman, x sub 1, multiply natin sa dependent variable value of observation 1. Then, same goes to other observation. Same concept here. X sub 2 multiply to the value of y. Observation 1, 2, 3, and 4. And then this one will have to compute for the, we'll have to multiply the value of both independent variables. So, x sub 1 times x sub 3. Alright. Now, if we have done computing the individual value of these guys, alright, then we can already get the summation value of all these data set, of all these guys. Alright. Sum. Right? Then same goes to other. And actually, we can also get, if you want, the value of the mean, the average value or the mean value. Average. Right. And then multiply it here. Then after we get here, we can now already substitute the value in here in order for us to get the results of the beta 1. Now, after we compute the value of the beta 1 and the beta 2, we can then substitute this value into here to get the beta 0. All right. That is basically how we compute for the marginal probability effect of the regression analysis. Now, I have here prepared a result of the regression analysis using Microsoft Excel. Basically, what I did here is that I ran a regression analysis using these data sets here. Using these data sets. Niran ko po ito, ginamit ko po, nag-run po ako ng regression analysis for this data set, and this is the results. No? So basically, the results goes like this. Since this data set is a false data set, therefore it is not valuable enough to interpret this. So what I am implying here is that let's focus on the results of this table, the marginal probability effect. Because what I am going to show is that where did you see the result, the value of beta O, beta 1, and beta 2? Saan po natin makikita ito sa multiple regression analysis output? So, si beta O, as what I said earlier, this is the y-intercept. The y-intercept. So, pag tinabit natin y-intercept, that is the intercept in terms of output of the multiple regression. So, ito po yung value ng y-intercept. While these two guys here, the regression coefficient 1 and 2 is this one. Alright, so x1 and x2. Now, the computation of individual hypothesis testing is different pa in terms of computation. Ano? The t-stat, these two guys here has this different computation in order for us to get the significant p-value of this coefficient. So magkaiba pa yung computation niyan. Aside pa diyan, magkaiba din, hindi natin na-compute yung results ng ating multiple R, adjusted R square and the analysis of variance. But basically, in terms of the R square, yung R square po natin is basically a Pearson correlation raised to the power of 2. Alright? Ang R square po is makukuha natin by raising the value of our R into 2. Again, pag meron na po tayong value ng multiple or the Pearson correlation, in this case multiple kasi dalawa yung ating independent variable. So kapag meron na tayong value neto, ang gagawin lang natin is to multiply or raise the value of this into 2. Right? Then we have the same, then we get the same results of the R on the R square. I did not include this in our presentation because Pearson correlation basically was already discussed to us by other groups, di ba po? That goes exactly the same to the analysis of variance. Na-present na din po to. Now, ang kaibahan lang po in terms of analysis of variance in terms of regression analysis, the difference lang po is that instead of using n minus 1 is as the degrees of freedom, we use n minus k. Alright? But basically, in terms of computation, parehas lang din po. Halos parehas lang po. Alright? Now, the question is, paano po natin na-compute or ginawa itong regression analysis sa Excel? Alright? I know sa Excel natin to kinuha, pero ang tinutumbok ko po is the process. Ano po yung proseso para po makapag-conduct tayo ng regression analysis sa Excel. Alright. Now that topic will be discussed to us and present to us by my group mate, Ma'am Cheryl Rosario. And basically, Ma'am Cheryl will present the uh, regression analysis using Microsoft Excel. Ma'am Cha, the floor is yours. Take it away.